Let's try problem 7.38. You've lift the front wheel of a poorly maintained bicycle off the ground and then started spinning at 72 revolutions per second. Friction in the bearing causes the wheel to stop in just 12 seconds. If the moment of inertia of the wheel about its axle is 0.30 kilogram meter squared, what is the magnitude of the frictional torque? Okay, so we have a wheel that's rotating with some angular velocity, which is equal to 0.72 revolutions per second. So the first thing to do is just convert this from revolutions per second over to radians per second. So we know that there's 1 revolution in 2 pi radians. So revolutions canceled, and we're just left with radians per second. And this comes out to 4.5 radians per second. Okay, now that we have something we can work with, we know that the friction in the bearing causes the wheel to stop in just 12 seconds. If the moment of inertia of the wheel about its axle is 0.30 kilogram meter squared, what is the magnitude of frictional torque? Okay, so we know that the magnitude of torque can be given by its moment of inertia times the acceleration. But we're only given the angular velocity and the time that it takes the wheel to stop. But we can get acceleration from that. So we know that acceleration is equal to the change in angular velocity over the change in time. And we know this numerator, we know the denominator. So W final minus W initial. So omega final is just going to be 0, right, because it's coming to a stop. Minus the initial velocity, which we just calculated up here, 4.5 radians per second. Over delta time, which is going to be 12 seconds. So this actually comes out to negative 0.38 radians per second squared. So now we have our acceleration. So now filling this in for the net torque. So know that the net torque on the wheel is going to be the moment of inertia times the acceleration, which we calculated over here. The moment of inertia is just 0.30 kilogram times meter squared times the acceleration, which is going to be negative 0.38 radians per second squared. Then we put this in the calculator, we get negative 0.11 Newton meters. But again, we're asked for the magnitude of the frictional torque, and so we just do the absolute value of that, and so this comes out to 0.11 Newton meters. So this is a torque that is required to make the wheel stop in 12 seconds, and that's 7.38.